All right, so based on the Google form response, we're going to go through these questions here, listed at the top. So 6, 7, 8, 9, 6, 7, 8, 10, and 12 are ones that I do expect you all to be able to do. Those are um, regular up to mastery type questions. A lot of you are actually doing it correct based on the answer you gave, but you didn't follow through with what the answer wanted. Some of you, the question said how many total, and you gave me the part of it. And some of you, it was vice versa, where you gave me the total amount when it was asking specifically for one of the parts of it. 13, 14 are the exceeding. I am going to go through it because based on a couple of your answers, I could tell that some of you are really close. So I just wanted to show you kind of how you can go through and do them. So let's go ahead and get started with question number 6. Remember, there are different ways you can do this. I showed you guys tape diagrams that you might have used last year. We set up proportions. Some of you are logically filling it through and showing the ratios and kind of multiplying the ratios up. That's perfectly fine. It's up to you with how you want to do it. But certain questions I might show you one way, I might show you different another way as well, but it's up to you with how you want to do it. So here it says the ratio of the number of adults to children in a park is 4:3. So I might just take note and say, okay, they're giving me adults to children, so they're giving me a part to part type question, because this is just going to allow for me to see, is it being consistent throughout the question, or do I need to manipulate my ratio? If there are 36 children, how many total people are in a park? So now we're going part to whole. So that means if I want to create my proportion or whatever I want to do with it, I need to remember that the ratio is not in the way that the answer or that the information is given to me. So I'm going to develop my plan. I'm going to do ratio and I'm going to do real because we're talking about real, the amount of people we have. So in our real, we know we have children to the total number of people. So that means my ratio must also be children to the total number of people. So the original one they gave me was adults to children, and they said it was 4:3. Well, that means that the part of this ratio for my children is 3. So I'm going to go ahead and rewrite that as 3 over. And remember, the total is saying the adult and children combined. And we can get that through addition. And even though 4 and 3 don't represent the actual number of people we have, it's its simplest form. So we can add them together and it will still keep our ratio intact. So that means 4 plus 3 is equal to 7. So we can then compare children to the total number of people as 3 to 7. And now when I go to the real one, they tell me that there's 36 children, and we don't know how many total people are. That's what we're trying to solve for. So by writing it out first, it's just allowing me to develop a plan. It's allowing me to make sure I'm being consistent. And now I'm going to set those two fractions equal to each other. 3 over 7 is equal to 36 over t. So some of you are now figuring out what it takes to multiply 3 to get to 36, and that's perfectly fine. But I'm just going to continue to go through our cross multiplying. So we can multiply our one numerator with the opposite denominator. So that would then give me 3 times t, which is 3t. And then the other numerator times the other denominator, which is then 36 times 7, which is then going to be 252. So I know 3 times t is equal to 252. And now if these two numbers multiply and give me 252, and I know it's 3 times something, well, as we talked about in class, the opposite or inverse of multiplication is division. So I can go ahead and divide each side by 3. And by doing that, when we divide and multiply by the same number, it isolates that variable and we have one of them. And 252 divided by 3 is equal to 84. So that means that there are 84 total people in the park. All right, there are different ways you can go about doing this. This is just one of them. All right, so for question number 7, it says Jay and Lorenzo both ran for student council. The ratio of votes for Jay to the total number of votes received is 7 to 11. So here they gave me part to whole. If Lorenzo received 200 votes, how many votes did Jay receive in total? Or how many votes did Jay receive? So this one gets kind of tricky because the ratio they give me is Jay to the total. But in our real scenario, they gave me Lorenzo. So that means I need to manipulate and rewrite this ratio in terms of Lorenzo. And I can write it in any way. I can write it Lorenzo to J if I want. I can write it Lorenzo to total. It's up to me. I'm going to choose Lorenzo to J. And the reason is the question wants to know how many votes J receives. So ultimately, I'm going to create the ratio of Lorenzo over J. So if J received had the ratio of 7 to 11 to the total, well, if we want to then work backwards to Lorenzo, that means that the missing part of this is 4 parts. So that means that Lorenzo must have 4 parts of this in order for it to have the ratio of 7 to 11. So that means that the ratio of Lorenzo to J is equal to 4 over 7. We know J was 7 on the question. And since the total was 11, that means the missing part that would add up from 7 to 11 is 4. So now I can go ahead and fill in, well, Lorenzo received 200 votes. So this would then be 200 over J. So now I'm going to go ahead and set these two ratios equal to each other. So now I get 4 over 7 is equal to 200 over J. And now I'm going to show you what some of you are doing as well. So So I know 4 times 50 is going to give me 200. So that means I need to stay consistent with the other one as well. So 7 times 50 is going to give me the amount of J's votes, which is then going to be 350 votes. All right, you can still do cross multiplying. You can use this method. I'm just going to go through and show you some of the ways I'm seeing you guys do it in class, just so that others are aware of it as well. If any of these other methods confuse you, just keep using the one that you're doing. All right, so for this one, there are 3 different people that are part of this ratio. So Amanda, Brian, and Emily share a prize of $600. They divide it in a ratio of 8 to 3 to 4. How much does each person receive? So I'm going to do this one in a different way. So the 3 ratios that we have Amanda, and she was a 8. So 1, 2, 3, 4, 5, 6, 7, 8. Then we had Brian, and he was 3. And then we had Emily, and she was 4. So we can draw these tape diagrams. And since they said that they shared a prize of $800 or $600, that's the total amount. So now I know each of these boxes represent the ratio, but they all represent like the same amount because the ratios are completely simplified. So what I'm going to do then is I'm going to count how many total boxes we have. Well, we have 8 with Amanda, we have 3 with Brian, and 4 with Emily. So 8 plus 3 plus 4 is then equal to 15. So there's 15 boxes that will give us a total of $600. So we can figure out how much is in each of those boxes by dividing 600 by 15. And 600 divided by 15 is equal to 40. So that means every single one of these boxes represents $40. So then if I want to figure out how much money Amanda has, well, I can add 48 times, or I can do 40 times 8, which is then going to be, let me just move this over, which is then going to be $320. So that means Amanda has 320. Brian, I could do 40 added together 3 times, or 3 times 40, which is equal to $120. And for Emily, I can do it 40 added together 4 times, or 4 times 40, which is then equal to $160. All right, so this is another way that you can do this by using the tape diagrams. Sometimes each type of question might lead to be the better version to use, or better thing to use. Like if our ratio was really big, like 27 to 13, do you really want to draw out that many boxes to visually represent this? Maybe not. So maybe you might want to use a different method. So each question kind of allows you to use one a little bit better. This one you could have used proportions, but doing it that way, you would have had to set up and solve it maybe a little bit more, a few more times, which is why maybe the tape diagram could be the best one to use for this. But it's really up to you. All right, so this was one that a lot of you, I could tell, did it right. You just didn't answer the question. The ratio of roses to tulips in the garden is 3 to 4. If there's 24 tulips, how many total flowers are in the garden? Well, roses and tulips are both flowers. So we're finding the total amount. Some of you just found out how many roses there were and gave me that as your answer. So make sure you're adding them together to get the total. So here my ratio is in roses to tulips. But my real that I'm trying to solve for is they give me tulips and then they want the total. So now I'm doing tulips to total. So I need to rewrite this as tulips to total. Well, if my ratio of roses to tulips was 3 to 4, I know that my tulips is going to be 4, and my total is how many parts I have combined, which is 3 plus 4, which is 7. So the ratio of tulips to total is 4 to 7. So now the amount of tulips I had was 24, and I don't know the total, which is X. So I'm going to then create a proportion, the two ratios equal to each other. And then just to practice going over cross multiplying again, I'm just going to do that method. So we have 4 times x, which is 4x, and now we have 7 times 24. So now we get 7 times 24 is equal to 168. So we have 4x is equal to 168. And remember, if 4 times some number is 168, we can figure out what that other number is through division. So if I divide 168 by 4, x is then equal to 42. So 42 total flowers. A lot of you gave me 18 as your answer, which showed me you knew how to solve for missing parts, but you just weren't solving the question that was being asked. All right, so for this one, a lot of you were answering this question, but weren't, same thing, answering what the question actually asked. So I knew that you guys are getting it right for being able to solve, but then you weren't converting it at the end. So it says a bus travels 120 miles in 3 hours at a constant speed. So it means that we're just imagining that it's not stopping at stoplights. It's just going at a constant speed of 120 miles in 3 hours. How many minutes? I bolded it and underlined it for you. How many minutes will it take to travel 200 miles? So I'm going to solve this one a little bit differently because we learned rates. So the first thing I'm going to do is figure out, well, how many miles does this bus travel in an hour? So I know that they traveled 120 miles in 3 hours, and that's equal to 40 miles per hour. So then in this case, if they're traveling 40 miles per hour and they travel 200 miles, I can figure out how many hours it is now. I can do it as a ratio if I wanted to. 40 over 1 is equal to 200 over x because I know it's miles over hours. So then from here, I can figure it out that way. Or I can then say, well, if they travel 200 miles and they're doing 40 miles per hour, I can do 200 divided by 40, which is 5, and that will tell me how many hours it will take. And some of you gave me that answer as 5 hours. However, the question said how many minutes? And there are 60 minutes in 1 hour. So now we would have to do 5 times 60, which is equal to 300. So it is 300. So it is 300 total minutes. All right, so for this question number 13, exceeding, I do think that the easiest way of doing this is through a tape diagram. So that's going to be the way I show you. So it says you and your friend each have a collection of tokens. Initially, for every 8 tokens you had, your friend had 3. So that means the ratio of you to your friend was 8 to 3. So I'm going to go ahead and draw this out. 1, 2, 3, 4, 5, 6, 7. So there's 8 to 3. So that's the original initial ratio. So I'm going to put a little line here because this ratio is going to change. It says after you give half of your tokens to your friend now has 18 more tokens than you. So that means of this part I have here, I gave half of them to my friend. Well, there's 8 boxes. 1, 2, 3, 4 boxes would represent half. So I'm taking these 4 boxes and giving them to my friend. So that means now I have 4 boxes remain over because I had 8 and I gave half. And now my friend has 3 plus the 4 I gave them. So they have 7 boxes. And now after I did that, they have 18 more tokens than me. So that means these 3 boxes here represent the amount of more that my friend has, and it's 18 total tokens. So I can do 18 divided by 3 because that's how many boxes there are. So that means each box represents 6 tokens. So in the original, each of these boxes still represented 6 tokens because we didn't change anything about saying like, oh, there's a new ratio that was established. We just said that after we gave them half, that they now have 18 more. So the amount that's in each box never changes. So then from here, we can then say, all right, well, each of these boxes, because it says how many tokens did you initially have? Well, each of these boxes represented 6, and 6 times 8 of those boxes equals 48. So we had 48 tokens to begin with. All right, so for this 14 question, there are 2 different games that happen. So I'm going to say game 1 and game 2. And it says the ratio of sold tickets to unsold tickets, so sold to unsold, for the first game was 7 to 3. And the ratio for the second game of sold to unsold for game 2 was 13 to 2. There are 240 unsold tickets for the second game. How many tickets were sold for the first? These ratios change. 7 to 3 is not equal to 13 to 2. They're not representing the same ratio. The only thing that cannot change between these two games is the amount of seats in the stadium, meaning the amount of tickets that we could sell in general, the total number of tickets. The stadium can't change from game to game. We can't make it smaller or bigger. It is what it is. So that means what I need to do is figure out, well, how many total seats are there? If I can figure that out, I can figure out anything with this problem. And since they tell me how many unsold tickets there were for the second game, using game 2, I can figure out how many total tickets there are. So I'm going to manipulate this ratio. Instead of it being sold to unsold, I'm going to do unsold to total because they tell me how many unsold tickets there are, and I can figure out the total ratio because they give me sold and unsold. So the ratio of unsold tickets to total tickets is 2 to 15 because we know that there was 2 unsold parts, 13 sold parts, so total it's 15. Then they tell me that the amount of tickets unsold is 240. So this is my ratio. I'm now going to figure out the real, and the real is 240 over the total tickets we don't know. So now I'm going to create the ratio of 2 over 15 is equal to 240 over t. I'm going to solve this one using cross multiplying just to practice it. So we do our numerator times the opposite denominator, so 2t. And now we would do 15 times 240. And remember, you are allowed to use a calculator. So even though this is going to give you a bigger number, you are allowed to use a calculator. So now we get 2t is equal to 3,600. And if I want to solve 2 times some number is equal to 3,600, well, I divide by 2. And that means that t, or the total amount of tickets, is 1,800. So there's a total number of 1,800 tickets that we can possibly sell in general. So now I'm going to go back to this game 1. And we know that there's 1,800 total tickets. They want to know how many tickets were sold in the first game. So now I'm going to rewrite this ratio as sold to total. Well, there's 7 parts for the sold tickets. And now 7 plus 3 is 10. So this ratio is 7 to 10 in sold to total tickets. So 7 to 10 is equal to, well, we know there's 1,800 tickets. So I'm going to write 1,800. And we don't know how many sold tickets. So we are just going to represent that as x. We are going to cross multiply. So we get 10x is equal to 7 times 1,800. And 7 times 1,800 is going to give me 12,600. So 10x is equal to 12,600. Then we'll divide each side by 10 because 10 times some number. So we're going to isolate that number. And that is going to give me 1,260. So 1,260 tickets were sold for that first game. There's different ways you can go about doing this. That's not the only way, but that's just the way I thought was the most direct.